Hello and welcome. I want to thank you for joining us for the presentation, Bringing RFID to Electronics with Monza X Chips. We truly appreciate your time and look forward to answering your questions at the end of the presentation. My name is Jill West, Senior Marketing Communications Manager at Impinj. Joining me today are Nikhil Dulkar, Impinj's Senior Product Line Manager for our Monza Tag Chip product line, and Vince Pescio, Vice President and General Manager at QuikQ. Nikhil will start today's presentation off with an overview of Monza X and then get into more details around product features and usages. We'll then hear from Vince of QuikQ about how he and the QuikQ team have been working closely with Impinj to take advantage of Monza X and their existing RFID infrastructure for truck fuel management. Then Nikhil will come back and talk about some of the practical aspects of starting development work with Monza X chips, such as where to get technical app notes and product support. We will be addressing all questions at the end of the presentation. If you take a look at the right side of your screen, you will see a question and answer box. If you have a question at any time during the call, please enter it in the box. If we're unable to answer your question during the call, we will follow up with you offline. Okay, with that, let's begin. Nikhil?
Thank you, Jill. Hello, everyone. I'm Nikhil Dulkar, Senior Product Line Manager for Monza at Impinj. And on behalf of all of us at Impinj, I would like to welcome you all to today's webinar. Now, for those of you who don't know Impinj, let me start off by describing the company and our products. Impinj is a leading provider of UHF RFID products. We have three product families: Monza, Indy, and Speedway. Impinj Monza tag chips are the highest selling UHF RFID tag chips on the market. Our Indy reader chips power most of the UHF RFID reader devices on the market, and our Speedway readers are the most widely deployed UHF fixed readers today. As a result, we have a very unique position and perspective in this industry. We see technical and business trends from both the reader and the tag side, and this enables us to bring exciting innovations to the market that create new opportunities for our end users as well as our channel partners. Today, we'll focus specifically on UHF RFID and electronics. Over the last few years, retail apparel has been the biggest market segment for UHF RFID. Success in this segment has driven the adoption of UHF RFID in other segments, such as electronics. And today, we see electronics being tagged for various different applications. Asset management and supply chain have emerged as the primary applications. We see several deployments where laptops and servers are tagged by IT departments in order to more efficiently track those company assets. Several other high potential applications are coming up. One of them is brand protection, which involves using UHF RFID to verify that the electronic product is authentic, meaning it's not a duplicate. Another application which is poised to take off is the authentication of consumables such as genuine ink cartridges for printers. And lastly, PCB tracking is another application that is gaining popularity. This involves using a tag in the PCB to store information about the components that are assembled on the PCB through the manufacturing process. This leads to higher manufacturing accuracy and efficiency. Now, while all of these are some great usages and applications of RFID for electronics, they're all very much rooted in the traditional use of RFID for any other goods. For the most part, RFID for electronics is moving forward just like RFID for t-shirts. So the question is, can we do better? And we absolutely can. When you combine the intelligence of a microprocessor chip with an RFID tag chip, some exciting new opportunities open up. Over the last 3 years, Impinj has worked closely with Intel, the world's #1 microprocessor chip company, on the research of this concept, leading to the development of Monza X chips. These Monza X chips not only have the regular UHF Gentoo interface for RF communication, but they also support communication through a standard I2C serial bus. So microprocessors can access the data stored in the tag chip, which is embedded into the device. At the RFID Journal Live conference this year, Intel delivered a keynote presentation about their vision for such intelligent RFID embedded in their upcoming computer platforms. The Monza X family of chips was announced jointly by Intel and Impinj in this keynote. You can see in this picture Shahrokh Saidzadeh from Intel, joined by Impinj founder and Chief Technology Officer Chris Diorio on stage for the keynote. At this event, Intel and Impinj also jointly demonstrated early prototypes of Windows 8 tablet computers with Monza X chips embedded inside them. These tablet computers are expected to be available later this year with the launch of the Windows 8 operating system. The demo showed off a usage model called Locked in Transit. This demo showed how Monza X can be used to deter theft of high-value electronic devices in the supply chain. The concept is very simple. These tablets are built with Monza X and an antenna directly embedded onto the PCB. After the tablet is manufactured and ready to be shipped out, a code is written into the memory of the Monza X through RF using a UHF Gentoo reader. This code locks the tablet. Now, if someone steals a tablet when it is being transported or when it is at the distribution center, the tablet either fails to start up or does not function fully. Every time someone tries to start it up when it is in this locked state, the microprocessor inside the tablet accesses the code inside Monza X through I2C and recognizes that it has been instructed to be locked. Now imagine that the tablet is delivered to the retailer and a customer purchases the tablet. At the point of sale, the retailer can use a Gentoo reader to write a code into the memory of the Monza X, instructing the microprocessor to unlock the tablet. All of this happens while the tablet is still unopened and inside its box. So what is Monza X? Monza X is our extended feature RFID tag chip line. The X stands for extended. We have announced two products in this category, the Monza X2K Dura and the Monza X8K Dura. Both of these chips have the I2C link for microprocessors in addition to the UHF Gentoo RF interface for communication. It is important to note that I2C is an open standard and several different categories of microprocessors, including ARM microprocessors, support this interface. The primary difference between the two chips is the memory size. The X2K has 2 kilobits of user memory, while the X8K has 8 kilobits. Both of these chips are available in QFN packages. These chips have two fully independent antenna ports. Now, for those of you are familiar with the True 3D technology, this is just like our Monza 4 chips. These chips add up the power from the two independent antenna ports, resulting in higher sensitivity and read range. Also, the two independent antenna ports enable additional versatility. They can be configured into any combination of near and far field antennas. For example, in this picture, we show one such configuration. In this case, one antenna is a near field loop antenna, and the other antenna is a far field dipole antenna. The near field antenna could be used in PCB manufacturing process to keep track of embedded components, while the far field antenna could be used after the device is fully assembled for communicating with UHF Gentoo readers. Also, another new capability and a first for Monza chips is the battery-assisted passive mode. These chips are capable of fully passive operation where the power is delivered wirelessly through the reader device. And they're also capable of improving their read range using additional power if delivered to the DCI pin that you see in this picture. Now let's look at some of the applications and usages that these chips enable. A key new capability enabled by Monza X is the ability to communicate with and configure devices while they're off and possibly inside their box or the original package. One way to take advantage of this is late-stage device configuration. So if you have an electronic device such as this TV that is shipped to different countries with a different default language setting, you can use Monza X to store the language setting, possibly just before shipping the device out. This can dramatically reduce the need to forecast and manage inventories of multiple SKUs of the device. Also, Monza X can be used to deliver upgrades such as service bundles with the device. For example, now you can see in this case, you can deliver a video streaming service upgrade right out of the box when this TV is delivered to the customer. Similarly, IT departments can automate the configuration or provisioning of devices, such as network settings for printers, by writing the settings into the Monza X instead of doing the work manually one by one on each printer. Now, the first question that most people raise about these usages is about data security and privacy. I've heard people say that the password protection on UHF Gentoo chips is weak and easily hackable. In the case of the tablet locked-in transit usage model, the question is, how easy is it for the thief to just write an unlock code into the tablet? Now, this is where the design of the Monza X chip has benefited greatly through our collaboration with Intel, who has dealt with system security issues over many years. The advantage here is that the connection to the microprocessor. That connection brings the kind of security that the microprocessor brings to any other communication component, such as Wi-Fi or Ethernet. The microprocessor can be used to encrypt and decrypt data so that only encrypted data is stored in the Monza X chip. So the system designer can take advantage of well-known and proven security techniques such as public-private keys. Another important security feature in Monza X is the ability to permanently lock sections of the user memory. More commonly known as per-lockable memory blocks, this feature can be used to prevent tampering of data after it is written into the Monza X. Impinj's patent-pending QT technology is also supported on the Monza X chips. QT technology allows the chip to switch from a private profile in which all of the user memory is accessible by the reader to a public profile in which the user memory becomes inaccessible to the reader. The advantage with Monza X is that this switch between the public and the private profiles can be controlled through the microprocessor through the I2C bus interface. And lastly, for those applications that need the RF communication to be switched off at a certain point for privacy reasons, the microprocessor can ask the Monza X chip to selectively disable RF communication through both the antenna ports or to either one of them. So in the case of the tablet computer that I described before, it is possible for the manufacturer to program the tablet to switch off RF communication as soon as the tablet is unlocked, so that the Monza X chip will not be accessible to UHF Gentoo readers. Now here's an example of using encryption through Monza X. I'll describe this use case with a laptop as a target device, but you can imagine similar usages for tools or weapons whose operation needs to be restricted to only certain locations. In this setup, bank employees have laptops with Monza X chips inside them. While the employee is inside the bank building, she has access to confidential customer information. This access is enabled by a secure encrypted code that is written into the Monza X chip by UHF readers every time the employee tries to access the confidential information. Now, when the employee is outside the bank building, say inside a coffee shop, she cannot get access to the customer information because in this case, the laptop does not find the properly encrypted code inside Monza X. Here's an example of how the multiple memory blocks and the block permalock capability can be used. In this case, the Monza X is inside this air conditioner. The manufacturer of the air conditioner has assigned specific uses for 3 user memory blocks. The first user memory block is used to store some basic information about the air conditioner, such as its model and serial number and the manufacturing date. This first user memory block is permanently locked so that this information, which really is the birth record of the air conditioner, cannot be changed or tampered with later. The second user memory block is allocated to the contractor who's responsible for installing and maintaining the air conditioner. The contractor uses this to save relevant information such as when the air conditioner was last serviced. And the third memory block in this case is allocated to the returns department. This is where the air conditioner can write information about itself. We can see here that this air conditioner has in fact written its status as failed, and the error code associated with that failure points to an issue with the compressor. So when this air conditioner is returned, the returns department can quickly and efficiently find out where to start with the repairs. Now, one key new capability that Monza X chips bring is their battery-assisted passive mode of operation. In the fully passive mode, Monza X has read and write sensitivity of -17 dBm and -12 dBm respectively when using only one of the 2 antenna ports. But when DC power is supplied, these chips get a boost in sensitivity and start performing at -24 dBm. Now these units are on a logarithmic scale, so to give you some context of the read range, we observed 15 meters read range with fully passive operation of a Monza X tag. And after DC power was applied, that same tag's read range was boosted to 32 meters. This extended range, when powered by a battery, enables usages such as wireless displays, sensors, and data loggers. So let's look at some of them now. These wireless display tags contain 3 major components. The LCD, or a low-power e-ink display, which is driven by a microprocessor. And the microprocessor gets its data for updating the display from the Monza X chip. So now a UHF reader can be used to write values into the Monza X wirelessly, which then the microprocessor can pick up and display on the screen. One common application of such displays are electronic shelf tags in retail stores. They can be used to reduce manual labor and also improve the accuracy of labeling prices of goods on store shelves. The standard I2C bus also enables the design of sensor tags with Monza X. Monza X is an I2C slave device. Most I2C sensors are also slave devices. So in this setup, the microprocessor, which is the I2C bus master, can read data from one or more of these sensors and write it into the Monza X chip. A UHF reader can then pull that data out wirelessly through RF. The frequency at which the data from the sensors is logged in to Monza X chip can all be programmed through the microprocessor. And speaking of data logging, there are several applications that can be enabled by Monza X. Here is one. In this case, it's a power meter. In most countries, the process of getting the power meter readings from homes is still a very manual process, where employees of the power company have to look at every meter to record the readings. Issues with this process include human error, labor, and in some cases fraud. So by using a Monza X inside the power meter for logging the readings and then transferring them upon access through the RFID readers can speed up this process dramatically and also reduce the errors and the opportunities for fraud. To describe another very interesting application using Monza X, I would now like to introduce Vince Specchio. Vince is Vice President and General Manager at QuikQ, and he has kindly agreed to share how they're using Monza X in their truck fuel management solution. So let's hear from him now. Vince?
Thank you, Nikhil. Good afternoon. I'm Vince Specchio with QuikQ. Thank you for your participation. In order to explain our unique use of the Monza X chip, I thought it pertinent to explain our industry and how we got to the use of the Monza X. We are a software development company specializing in improving the fuel management process in the trucking industry through current and emerging technologies. Fuel management is from the authorizing a fuel dispenser all the way to the back-end reconciliation. We have developed two product lines, DF Connect, which is a carless direct fuel connection between the truck stop and the motor carrier, and SmartQ, which is our integration of RFID technology to initiate a carless transaction for the driver at the truck stop. Let me start by setting the stage so you understand the why and how this technology is important to the trucking industry regarding fuel fraud. There are 2.8 million Class 8 trucks and 5.6 million trailers on the road today. The average truck driver drives 120,000 miles per year. Conservatively, a truck gets 7 miles per gallon. Each truck consumes 17,000 gallons per year. Annually, 48 billion gallons of diesel is consumed by trucks in our industry. That's a lot of gallons. These statistics are important as we move forward. There are two types of drivers in this industry. Company drivers, who are employees of the carrier company, and that company pays the fuel bill. Then there are owner-operated drivers who own their own truck and pay their own fuel. The old fuel methodology is for a truck driver to swipe a fuel card, much like a MasterCard or Visa. From a potential fraud perspective, you know the card is at the pump, but you don't know that the truck is truly there. The company driver's company pays for the bill from the fuel company. Typically, 5% of fraud is not detected. Companies keep track of the miles per gallon to try to detect this fraud. The average annual salary for a truck driver is $54,000. With the personal cost of living increasing, so does fuel theft. It is alleged that some company drivers may sell diesel that is paid for by the company owner, is paid by the company to the owner-operators to supplement their income. Perhaps sell $100 worth of diesel for $50 cash. Mentioned in the last slide, 48 billion gallons of diesel is consumed per year for the trucks in our industry. With diesel at $3.79 per gallon, the cost of fraud is $1.8 billion. In the end, this is passed on to us, the consumer. We looked for a technology that was feasible to create an infrastructure and the cost to implement at truck stops and the cost to carriers for their trucks and reefer trailers. Imaging was expensive to create 100% recognition of the truck and trailer. GPS was not accurate enough under the truck stop's canopy. However, RFID provided the accuracy and least expensive solution to the industry in its entirety. We looked at RFID tags, and active tags possessed a maintenance issue due to the battery required and the cost of the tag, and in many cases is a proprietary tag. Passive tags, however, provided a maintenance-free and low-cost offering, These tags also adhere to a Gentoo standard. With the Monza 4 tags, QT in particular, there is that public and private space that we were able to enable for our offering. Readers also had to be compact, rich in features, such as reduce or eliminate ambient noise. For example, CBs. Believe it or not, they're still used in the trucking industry. The readers had to be reliable, a low failure rate, and basically the cost of ownership was important. The combination of our Impinj products enabled reducing fraud in our phase 1 of our solution at the Love's travel centers and travel centers of Industry now has asked for additional information from the truck that normally requires either an expensive mobile communication device or a shop engine device. With the serial connectivity to this RF chip, we're talking about the Monza X here, this enables us to develop both a tag with a serial cable to an interface device plugged into the truck's engine bus, if you will. There's an interface there. And on command, we can now request information from the engine and read this information via RF to the tag. As mentioned, we developed a device that communicates to the Monza X through the I2C interface that enables us to request engine data that can further secure and limit fuel transactions. For example, the VIN number. This guarantees that that tag is truly attached to the truck, therefore the fuel dispensed is going into that truck. Fuel tank level. We can now limit the diesel purchase to the size of the diesel tank. And further, there's odometer reading, which is used for statistics for the route of the load on the trailer, useful for the carrier themselves. Diagnostic fault codes enables the carrier to take preventative measures to keep that truck on the road longer. We also developed a universal Monza X tag. The cost of the tag had to be minimal, and the tag had to be multi-purposed. This development has a hard case metal Monza X tag with a tethered cable that can be attached to any interface device. Our current usage is for the truck. The universal tag is attached to the inside of the windshield with the tethered serial cable attached to the CAN bus interface device. We also use this universal tag attached to a reefer unit of the trailer. A reefer is a refrigerated trailer, for those that don't know the industry, to determine the amount of diesel that's needed from the tank information. In both cases, this further reduces diesel theft. Ultimately, the cost to ship goods would not increase due to fuel fraud. Thank you, and I hope you recognize other opportunities and usage of this new IC. Thanks, and Nikhil?
Thanks, Vince. Now, I will cover some more practical aspects of getting started with using Monza X chips. There are two products that we have announced, the Monza X2K Dura and Monza X8K Dura. As the name suggests, the X2K has 2 kilobits of user memory, while the X8K has 8 kilobits of user memory. Correspondingly, the size of the X8K chip is also a little larger. The X8K Dura has a 1.6 by 1.6 millimeter package, while the X8K Dura has a 2 by 2 millimeter package. Both of these chips have 128 bits for the EPC, and they are programmed with a 96-bit serialized TID number. X2K Dura is in production now and available through our distribution channels. And we have engineering samples of the X8K Dura available for our customers for testing and feedback. We expect to be in production with the X8K Dura product in September. Now, as you start thinking about your system design to use Monza X, there are multiple choices. The first one of these has both the Monza X and the antenna on the PCB. This results in a more integrated solution. The second option involves using an external antenna. So in this case, the Monza X chip is on the PCB, but it's routed to an off-PCB external antenna. The advantage with this solution is that the external antenna can be placed in a favorable location to achieve optimum read range. The third option involves keeping both the Monza X and the antenna off the PCB as its own tag that is connected to maybe an I2C header on the PCB. This results in a more modular solution. And then there is, of course, the option of using the Monza X tag by itself without connecting to the I2C bus. We have some customers who are already using Monza X2K Dura to develop such standalone tags. One of them I'd like to mention here is Xerify. Xerify plans to offer their Pico XL tags with Monza X chips due to their additional memory capacity. I would also like to point out that our goal is to make these two parts drop-in compatible. In order to achieve this, on the hardware side, we have a recommended common layout footprint. With this common footprint, customers can easily upgrade from an X2K to an X8K. On the software side, we have a platform-independent Monza X API for accessing the Monza X chips through the I2C bus. Again, this API is designed to abstract the details and memory map differences between the X2K and the X8K. So from the perspective of your application, there's a common API that is portable across the two parts and across microprocessors and operating systems. And to get started with developing applications or rapid prototyping with Monza X, we offer a development kit. This includes a development board with a Monza X chip on it. There's a dipole antenna attached on this PCB and connected to one of the antenna ports of Monza X. So this board can function as a tag and be read by UHF readers all by itself. The second antenna port on the Monza X chip on this PCB is connected through a matching network to a port into which an external 50 ohm antenna can be connected. The header that you see on this board can be used to access the Monza X chip through the I2C bus and also to provide DC power. Through this header, an I2C to USB host bus adapter can be used for plugging into a PC. This way, whether you're developing on a Mac or a PC or a Linux PC or Windows, you can access the Monza X. You can even try out our sample application and also start developing your application with the Monza X API. And lastly, here are some technical resources available to assist you with your development. The data sheet is available to our website. Also, we have a couple of application notes that we can make available upon request. The first one of these is an antenna design guide with some reference designs. The second is an application note on software development using the development kit. And we're always here to help as well. To get further technical support, you can contact us at rfid_info@impinj.com. And that's the end of the presentation, so we're now ready to take some questions.
Okay, thanks, Nikhil. As Nikhil said, we're ready to take your questions, and I'd just like to remind you that if you have a question, please type it into the question box. And in the event that we're unable to answer your question during the call, we will be sure to follow up with you all offline. All right, so the first question we have is, of course, about the recording of the presentation. And yes, we are making a recording of the presentation, and we'll be making that available later this week. And we'll be sending that out via email and also have it posted on our website. And then the next question, this was, I think, related to the device lock in transit, and they said, or they asked whether the locking of the device really happens inside the Monza chip.
Yeah, so as you think about this usage model, think of the Monza X chip as the conduit for exchange of information with the microprocessor while the device is switched off. So the way this works is a secure encrypted token or code is written into the Monza X chip. So the Monza X chip in this case acts as the memory where that code is stored. The locking actually happens using a firmware that's on the device. That firmware, when the device is turned on, instructs the microprocessor to look at what code is inside the memory of the Monza X chip, and based on whether it's a locked code or an unlocked code, the device, the microprocessor responds correspondingly. So, the answer to your question is Monza X by itself cannot be used to lock the device. You need it's a combination of the microprocessor, the Monza X chip, and the firmware which locks the device.
Okay. And just to be clear, when you're talking about firmware and stuff, someone asked whether you can use LLRP to send commands.
Yeah, so you can use LLRP to send commands to it through a UHF Gentoo reader. From the UHF Gentoo reader perspective, that whole wireless RF it follows the standards, so the chip should look exactly like our other Monza chips, including Monza 4 and Monza 5.
Okay. How much power does it take to write to and read from the on-chip memory, and is this memory EEPROM?
So I don't have the specific power values with you, so I can answer this question in email later.
Okay.
The short answer, though, is the characteristics of this chip are similar to the Monza 4 chip. So those power numbers, if you look in the data sheet, will be similar to what you see in Monza 4.
Okay. And again, the data sheet, as the on-screen says, is available on our website. And then there was a question about whether Monza X can work being attached on PET with printed silver ink antenna inlay.
So the form in which we are bringing Monza X to market today is in a QFN package. In that form, we don't expect the chip to be mounted onto that PET kind of an inlay. If you are interested in that kind of a usage model, we'd encourage you to contact us. We might have some options for you, but at this point we're not making that available as a standard product.
Okay. And can you talk about the availability and cost of the dev kit?
Yeah, so we have a Rev 1.0 version of the dev kit available today. We are working on a second revision of it, which we expect to have in about a month's time. But the 1.0 Rev is good enough to get started as well. As far as the cost of the dev kit, again, I would encourage you to contact us, and we'll work it with you in terms of the pricing.
Okay. And can you also get samples of Monza X?
Yes, absolutely. The samples of Monza X are available, both the X2K and the X8K. The X2K obviously will be the production samples. This is the product that we're selling today. The X8K, you will get the engineering samples, and that's what we have available today. But to get those samples, again, please contact us at RFID_info@impinj.com.
Okay. And Vince's question's for you. Where are the readers installed in the QuikQ solution? Are they on the fuel pump?
No, they're not. They're in the canopy up in a NEMA 4 enclosure.
Okay. Let's see. And Vince, there was another question for you regarding the love sites that you've deployed already. Are you using the Monza X solution at those love sites?
Not at this moment. We're in a beta testing right now in a facility down here in Tennessee.
Nikhil, are there other readers, or could you talk about, I guess, the types of readers that can be used to write to the chip or interact with the chip?
Yes, the chip is fully UHF Gentoo compliant. So any reader that follows the UHF Gentoo spec should be able to write to this chip.
Okay. Can Monza X notify the microcontroller when it is read by an RFID reader? Does it send RF data such as RSSI, phase, or frequency?
Okay. There is a mechanism through which the Monza X chip can notify the microprocessor. It's not based on a read command. It's based on a write command. So the way this works is you can set Monza X to be used in what we call as the write wake-up mode. And once you've set it in that mode, you can obviously you can passively read that tag, but when that write wake-up mode is set, when you write to the tag, it will toggle one of the lines of the I2C bus. So it will toggle the SCL line on the I2C, and that toggle can be used to wake up a microprocessor or wake up the device. So that's the mechanism. What was the second part of the question, Jill?
Whether it was sending RSSI or phase or frequency information.
No, it does not have that.
Next question. Wanted to clarify whether the Monza X chip is coming integrated with the microprocessor or just the antenna.
The chip does not come integrated with the microprocessor. It's a separate chip, and it also does not come integrated with the antenna. The antenna is separate, and there are a few different ways by which you can connect the antenna. One is you could do it. You can etch the antenna directly onto the PCB, and another way is you can out an external antenna to the Monza X chip, which is on the PCB through a matching network.
Okay.
Now there are tag vendors out there who are working on some solutions integrating the Monza X chip with antennas. So those tags should be available in the market very soon. So if you're looking for a plug-and-play solution, those are coming to market.
Okay. Vincent, this is another question for you, whether you used an ATEX rated reader, ATEX.
Gen 2 should be able to read it, yes.
Okay, this question is, can multiple tags in the same field be written at the same time? And if yes, how many tags can be addressed at one time?
So the behavior here, again, is very similar to any other Gen 2 tag. So all those rules apply. So the answer is yes, you can have multiple tags in the field and be written to simultaneously.
Okay. Does the design application note provide design options or proposals for connecting external antennas to the UHF port of the Monza X?
Yes. The application note provides some guidance on how you do it in terms of etching the antenna on the PCB or using a slot antenna, taking advantage of the ground plane inside the PCBs, as well as attaching an external antenna. So all of those details are covered in the application note.
Okay. What language is supported by the API?
It's C.
Okay. This might be a technical question, but I will ask. When pulling a large amount of data through the tag from its memory or from the microprocessor via RF and a reader, how does the data link handle RF dropouts or interference that happen as part of the transaction, or interference that causes part of the transaction to fail? Does it have to start over?
I don't know the answer to that question. The way to look at it is no different than any other UHF tag when it comes to getting data. So the same rules of the protocol apply in this case as well.
Okay. What is the power consumption when this chip is operated in battery-assisted passive mode?
So in the idle mode, the chip, and when power is being fed to the battery, the chip consumes about 20 microamps. And during write operations, it can consume up to 50 microamps. So the power consumption would eventually depend upon your usage model. All depends on how many writes you have and what other components you have in the system.
Okay, and are there any uses of Monza X without the RF functionality?
Yeah, so one of the usages, or there are several other usages that some of our customers and end users are looking into. One of them is using the TID to uniquely identify devices. So you can think of applications where you need to protect your content or deliver certain content to a specific device, so they're using the unique identifier inside these chips to uniquely identify the device. There are other applications where the chip could be used primarily as just a memory storage location. So there are some security advantages with the chip in terms of being able to permanently lock sections of the memory, and that's interesting for some users.
Okay. This is a question related to the battery-assisted passive mode, I believe, that you just talked about, is how do you calculate the time for battery life?
So that would depend on your total system. The numbers that I provided are specifically for the Monza X chip. Now, depending upon which microprocessor you use and which other components are on your device, you would have a different number. We've done some calculations ourselves using, say, if you were to build a little price tag with the e-ink display and an efficient microprocessor, and depending upon which components we pick, we're seeing somewhere between, for that usage model, we're seeing somewhere between 1 year and 2 year lifetime.
Okay. There's a write wake-up mode feature in your data sheet. Can you explain what that is?
Yeah, I think this is related to one of the questions that was asked before, where you are able to you're able to set the Monza X chip in this write wake-up mode, and when a reader does a write operation, the chip can toggle one of the lines on the I2C bus, which works as a way of telling the microprocessor that a write operation has happened, or using it to wake up the rest of the device.
Okay. Okay, well, I think that we might have had a few more questions that I missed within the question log that I had here, but we will be sure to follow up with folks offline on those. And I want to thank you again for your time today.